Good morning, everyone. Myself, Priyadharshini, working as assistant professor in the Triple Department of R&D Engineering College. Today, we are going to see a topic in the unit 2. The topics are superposition theorem and the Thevenin's theorem. So, what is superposition theorem? The superposition theorem states that, so what it is stating, it is in any linear network containing two or more sources, the response in any element is equal to the algebraic sum of the responses caused by the individual source acting alone, while the other sources are non-operative. That is while considering the effect of individual sources and other ideal voltage sources and ideal current sources in the network are replaced by the short circuit and open circuit across the terminals. And this theorem is valid only for the linear system. So especially the superposition theorems are helpful in a circuit which is consisting of more than one or two sources. The next is in the superposition theorem. So what they are saying is the response is obtained by making one source acting alone and another source to be, while removing the current source, it should be made open circuit, and while removing the voltage source, it should be made short circuit. For example, and this is the circuit they have given. So here in this circuit, we are having two sources, and whenever I'm considering one source, I should remove the other source. For example, if I'm considering the 20-volt source, I should remove the current source. What is the procedure to remove the current sources? It has to be open circuited, and similarly, that is vice versa also. In short circuiting means I have to remove the voltage source and I have to short it. And if it's an open circuit means I have to remove it and the current is going to be zero. Okay, the question is find the current passing through 3 ohms resistor. So they are asking us to find out the current which is flowing through 3 ohms resistor. So the procedure is we have to consider one source at a time and find the current flowing through 3 ohms resistor. For example, if I'm going to consider only the 20 volt, I have to remove the 5 amps source. So they are saying 20 volt source is acting alone. Okay. So then the current I20, that is the total, is due to the 20 voltage source. The 5 amps source open circuited. If it is open circuited, so totally the current is not going to flow through this. Only this 5 ohms and 3 ohms are there. They are connected in series only because here there is no path for the current. So 5 plus 3 is 8. So 20 divided by 8 is 2.5 amps. So 2.5 amps is the current flowing through this path. So if the 2.5 amps is flowing, that is the current flowing through 3 ohms resistor when our 20 volt is acting alone. And if 5 amp source is acting alone, if this source is acting alone, this has to be short circuited. Okay. If it is short circuited, these two are the resistor. So this is my 5 ohms resistor and 3 ohms resistor and 10 ohms. So only this current is flowing through this. So whenever the current is flowing through this is the total current. So in that the current is going to get divided. So I'm going to apply the current division. So rule. We know what is the current division rule. If I want to find out the current flowing to 3 ohms resistor, and then total current is 5 amps. So 5 amps into opposite resistance is 5 ohms by total summation of the two resistance. So answer is 3.125 ohms. So we have found out what is the current flowing through 3 ohms resistor by considering 20 volt and 5 amps. So total current is 5.625 amps. The next is use the principle of superposition and find the current IL through 8 ohms resistance in the circuit shown. So in the circuit shown, we are asking us to find out the current flowing through 8 ohms resistor. Here also we are having two sources, one is the 10 volt, another one is the 5 amps. So the same procedure only, but the number of paths is going to get increased. So if I am using only the 10 volt, I have to open circuit. If it is open circuited, see here. If it is open, I am having two paths, then I should find out the current flowing through 8 ohms. Two method I can use, whether I can go with a mesh analysis or I can go with the network reduction method. So whichever is feasible, we can go with that. So then due to the 10 volt, the current flowing to IL is 0.5882 amps. So how to find out? A simple way is I can use the mesh analysis. So two paths are there. Or otherwise you start reducing the network, get the total current, and then you find out the current flowing through 8 ohms resistor. The next is The current flowing through 8 ohms resistor by using 5 amps. So how to find out? So total current is this, but I can't go with what to do current division rule. So many resistors are there. And then we are having the source transformation. 5 amps and 2 ohms are connected in parallel, and it has been converted into voltage source. And then after converting into voltage source, and this resistance will be connected in series. So here they have explained. And then you apply the Ohm's law, and you can get the current also flowing through 8 ohms. So they have said, and that is the one of the method. And here the one more method is here they are asking for total current. So then they are reducing the network. So these two are connected in parallel and reducing the network. Again, these two things are connected in series. Okay, so if I started reducing this network, the minus answer is minus 0.824. If I added both, I am getting this answer minus 0.3942 amps. The last is source transformation, the voltage source and current source. How to convert a voltage source into current source? Voltage source can be converted into the current source if the resistor, whichever is connected in series, that can be converted into parallel. I is equal to V by R. So V by R, and this resistor, whichever is in series, it will be connected in parallel. Okay. So determine the equivalent voltage source for the given current source. For example, this is 5 amps and 5 ohms. What is the equivalent voltage source? V is equal to I into R. 5 into 5 is 25, and this will be connected in series. So 25 into 5, this is the voltage source. The next is determine the equivalent current source for the given voltage source. This is my voltage source. This has to be converted into current source. So what is the value of the current? I is equal to V by R. V is 50 and R is 30. So then answer is 1.66, and whichever is in series, that will be connected in parallel. Okay. The next is the Thevenin's theorem. So Thevenin's theorem states that this is also suitable for a linear network having a number of voltage current sources. Resistance can be replaced by a simple equivalent circuit consisting of a single voltage source in series with a resistance where the value of the voltage is equal to the open circuit voltage across the two terminals of the network, and the resistance is equal to the equivalent resistance measured between the terminals with all the energy sources are replaced by the internal resistance of VTH and RTH. So here, VTH is nothing but Thevenin's voltage, and RTH is the Thevenin's resistance. We have to replace the resistance, and what is the voltage across the uh, resistance which is removed. And similarly, RTH is the equivalent resistance at that point. 10 volt, 2 ohms, 12 ohms, and 24 ohms. So here, so this is the thing. So they are asking us to find out the Thevenin's voltage and Thevenin's resistance. If this is the load resistance, we have to remove that and find the voltage across this terminal. So how to find out the voltage across the 24 ohms? 24 ohms and the 12 ohms, they are connected in parallel. If I found out this voltage, this is equivalent to this 24 ohms. And how to find out the drop across this 12 ohms? So I V is equal to IR. So 12 and 2 are connected in series only. So 12 plus 2 is 24. So V is equal to I is equal to 10 divided by 24. I will be getting the current, and that is multiplied with the 12 ohms. I will be getting that. So here they have explained that. So 10 into 12 by 14. So 12 is this 14. Answer is 8.57 volt. So we are using as a voltage division rule. And RTH. So we have to remove the resistance and find the equivalent resistance. These two will be connected in parallel. Answer is 9.7. So in the finally, in the equivalent circuit, it has been replaced 8.7 volt and 1.7 ohms, and load resistance IL is equal to VTH by RTH plus R. Similarly, like the Thevenin's theorem, the Norton's theorem is also there, but there is only a small change here. In the Thevenin's theorem, this is replaced by the equivalent voltage source, but here it is replaced by the equivalent current source with a parallel total resistance. So here that the current is called as IN, Norton's current or the short circuit current, and here this is the total resistance. And here this is 20 volt, 5 ohms, 10 ohms, the same problem only. And 6 ohms is the total resistance. What is the short circuit current? This has to be removed and short circuited and find the current which is flowing through that. And similarly, um, RTH. We find remove this and find the RTH and replace the 20 by 5 is 4 amps and RN is 5 by 15 amps. So that my final answer is. So here the problem is given as find the Thevenin equivalent circuit for this circuit which has been given. So this is the already it has been open circuit. We have to find out the VTH across the C and B. So for this, this is connected in parallel, right? But here we are having the source and the drop. So first to find the current flowing through the 6 ohm resistor, and that has to be uh, used along with this 10 volt. The answer is I is 2.5 amps. So if I'm using that, my VTH is going to be 25 volt. So then if I'm finding out the equivalent resistance, this is 6.75. If I'm substituting that, I will be getting the Thevenin's equivalent circuit. So in this video, we saw the theorems of superposition, Thevenin's and the Norton's theorem.